Hey, my two students, Mr. Mr. Yance. I hope things are going well for you. Uh, Going to kind of continue on with the little limnology notes, day 3. I mainly want to talk about, the big question is, how do we know our lakes, our ponds, our streams, freshwater ecosystems, how do we know if they're healthy or not? And how can we detect if they're not healthy? How do we know what is causing the problem? So there's a couple ways you can do water quality testing. This is the one that's probably that gives us the most information about what exactly is going on in our ecosystems, our freshwater systems. It's called a WQI, which stands for Water Quality Index. There's hundreds of tests you can run, and if you're working for the EPA or you're working for, an environmental protection group or environmental assessment group, you would go into a lot more chemical tests. But many years ago, I was very fortunate. I talked about this in class that I got to test on the Mississippi River, and this was back in the 80s, late 80s, and water quality was becoming a bigger issue all the time. And they wanted to come up with some basic tests that you could run at the high school level or at the middle school level. So we had teachers from all over the country come together and say, how can we affordably go out and test our pond at our school or a stream by our school or a body of water in our local community? How can we kind of get at least a little bit of an idea what's going on? So they came up with these 8 chemical tests, and I don't know if we're going to have time to do these. Usually I run all 8 of them on our pond. I've been testing the pond since the late 80s. I don't know if we're going to be able to physically go out there and do these tests because we just are running out of days with all this crazy year we've had. But I kind of still want to go through them and tell you what they mean and what they show. So there's 8 different tests. Dissolved oxygen, I'm going to go in the order of importance. So probably these first 2, if you're going to say, how can I go out there right away and when I test a pond or a lake or a stream, how do I know if it's got a problem? You can tell right off the bat with a dissolved oxygen test and a BOD, which goes along with it. A dissolved oxygen, I have sensors. We go out, we drop them in. They got a little dissolved oxygen sensor that hooks up to an iPad. We go out there, and we may do this test. You drop it in, and it gives you a reading how much dissolved oxygen is available to all the things living in there, all the fish, the turtles, the frogs, whatever. Okay. BOD, you do the same test, but you take a sample. You go and you put it in the dark for 3 or 4 days, so you shut off photosynthesis. Then you do a dissolved oxygen. That tells you how much of oxygen the little microorganisms using. So these 2 are the same test. They just tell you a different story. Okay. Temperature is a big one, and I'll break all these down and do a little more detail with them as we kind of go here. pH is pretty common test that we run on bodies of water. Turbidity, just simply how cloudy is the water. In northern Indiana, this is a huge issue. We got a lot of sediment. We got a lot of mucky types of bottoms in our bodies of water. Turbidity is something that does cause us some issues. E. coli and general coliform, pretty self-explanatory. What type of microorganisms that could be unhealthy. Sometimes you'll hear of them closing down beaches, closing down areas where people swim because of high bacterial counts. So that's what that is. Nitrates or nitrites, basically fertilizers, and orthophosphate goes along with that. So this is kind of the battery of tests we came up with. Someone a lot smarter than me, a professor actually from Southern Illinois that I went to the workshop with, kind of came up with some standards. In other words, what's normal and what's not normal with these 8 tests, and how can we go out there, get an accurate test, bring it back to the lab, and analyze it. That's going to be the huge determining factor. Okay, so they came up with this paper, and you're going to see they have a weighing factor. Some of these tests, you can see dissolved oxygen, fecal coliform are two of the higher importance to the health of a body of water, and then they kind of go down from there. So you come up with a number, you convert it into what we call a Q value. I'll go through all that with you later. And then you multiply it, and you come up with a number, and it tells you, is your water excellent, good, bad, very bad, fair, whatever, medium. I'm going to tell you right now, I've tested our pond for years, 20 plus years. It's changed a lot. I'll explain why as we kind of go through some of this. And it always is kind of test kind of in the medium range, not good, not bad, just kind of, in other words, you're not going to, we go canoeing on it. If you dump your canoe out and you fall into the pond, you're not going to come out and turn green and get sick. But I would not drink our water out of the pond either. So that's kind of where we're at with some of that. And the pond has changed a lot. We'll explain that too as we kind of go. Okay. Over the years, I just kind of wanted to show you a quick tour through some things I've done with my classes. We've always tested the pond because it's right outside our door, which is very fortunate. Not very many schools have a pond that they can walk out of their biology room like I can and go test and use. We've done a lot of testing on the Elkhart River. I actually had a summer group that we went out in canoes, and we did a lot of testing up and down the Elkhart River, all over the North Branch, the South Branch, and Ligonier, and over by Mauer's Roost, down by a chain of lakes where it gets its start. So we've done a lot of water testing, got a lot of data on that. I actually had a friend of mine who's a retired teacher now that lived on Lake Syracuse, and we would take his pontoon out and take students out. I'll show you some more pictures of that later. And we did some testing on Lake Wawasee, which is a huge body of water, right? And Eagle Lake. Took some canoes out. We tested some things on Eagle Lake, Ingle Lake. We've just done a lot of water testing in our local communities. And you can see we used to, and I wish we could go back to this maybe when we get out of COVID and get out of some of the stuff that we're doing now. I would love to go to, we used to take like 100 students, history, English, chemistry, biology, and we'd rotate groups, and we went to Indian Village, which is down 5 there, and we did some water testing there too. And that was a fun time, but we just haven't been able to, with the way curriculum has changed, just can't hardly do that now. But it is something that I've got a passion for. It's something that I've always enjoyed doing. And there you can see kind of our path we did. We did a test and went across Lake Syracuse through the wetlands and into Wawasee. Kind of crazy stuff back in 2000. Okay. So what is the WQI? I've changed my equipment. We've got a lot better equipment now. I've been very fortunate over the years to get some grants. So let's kind of go through some of these tests. So what are some of the tests we can do on the pond, lake, river, body of water? Water temperature is a big one. Very important overall water stream indicator, because temperature affects a lot of things. It affects your dissolved oxygen. It affects your rate of photosynthesis. Okay. Metabolic rates of aquatic organisms are affected. So obviously, with where we live in northern Indiana, we deal a lot with changes in temperature, obviously, with the seasons. You're not going to have this as much in Florida or California or, Arizona or someplace like that. So every body of water is going to fight water temperature, especially in a seasonal climate. But what we're talking about is extreme temperature differences out of the ordinary. Okay. Obviously, when the water's temperature is colder, the rate of photosynthesis slows down, dissolved oxygen actually goes up. A little chemistry, we'll talk about that. And obviously, the aquatic organisms are going to slow down in the winter, whereas in the summer, everything speeds up. Okay. So what we found is aquatic organisms have a narrow range of temperatures they like to live in. Warmer water holds less oxygen. It's a chemistry thing. You probably learned about that, maybe. Um, Actually, we have the highest dissolved oxygen readings in January, February, because the water is colder, it holds more oxygen, and the aquatic organisms aren't having the high metabolism, and that's going to lend itself to that too. What are some causes? The big thing that we deal with, especially here at West Noble, is we've taken all the trees off of our pond to make it look good, which I understand, and we get a lot of runoff from roads, parking lots. The pond, to kind of give you a little history lesson real quick here, the pond was put there not for us to study and be used for biology. We just kind of benefit from it. It was put there as a catch basin. So it's at the lowest part of our school campus. When we have a U.S. highway like U.S. 33, you can't have it flooded because it's a major highway. So when they built the schools and they started doing the landscaping and moving soil and stuff like that, they put the pond there so that it collects all the water so it doesn't flood 33. And you'll notice that the pond has a big circle thing out in it. That's the outlet. So it actually, when it gets to a certain level, it goes in and underneath 33 and dumps out into a little creek behind Stone Straits. So that's kind of the idea behind why the pond is there. Now, obviously, as a biology teacher, I want to use it for, studies and water quality testing and canoeing and things like that. So, it has changed a lot, and we'll talk about that. We don't get much discharge from wastewater industrial sources, but other bodies of waters do. So that's all going to affect the temperature. This is kind of a cool satellite picture. This is actually in Carlsbad, California, and this is a power plant. Power plants, the problem they have is they have a lot of warm water they have to get rid of, and they discharge it into the ocean or a big body of water, and it's really caused some issues in and around that. So we actually have a lot of laws in place now where you have to put that water in a holding facility, let it cool off, and then you dump it into a big body of water. Okay, you don't think of temperature as being a pollutant. We're thinking about industrial chemicals and things like that. You don't think of here's one on the Gulf, right? Look how warm it is discharging into the Gulf of Mexico. So, it's kind of one of those pollutants that kind of goes, under the radar a little bit, and it's something that is not a big problem in most places, but it can be in big industrial areas, big cities, things like that. Okay, we call it urban pollution sometimes too. Okay, and even in our little pond setting, you think about all of our parking lots and roof and how the water, when it rains, it's going to warm up and dump into the pond, but it doesn't cause as big a problem as it would in a bigger area. Okay, the big one that affects all bodies of water is dissolved oxygen. So I kind of want to quit on this one. So let's see if we can get through this one. And we'll call this set of notes good, and we'll kind of pick up on this later. So dissolved oxygen is one of the most important indicators for biology, aquatic organisms, plants, and animals. It's a great measurement of stream health. It's one of those you go out, it's an easy test. It really tells you right away, do I got a problem of some type? Okay. What are some things dissolved oxygen indicates? Warm temperatures can't hold as much dissolved oxygen, so obviously your water is going to change throughout the year. Altitude, atmospheric pressure, where are you at? Dissolved oxygen is going to be different in Colorado in the mountains than it is in Indiana or the East Coast. Okay, turbulence, that's the big one. If you can stir the water up, you probably know some places put generators and bubblers and diffusers and things to kind of keep the water moving. That helps with dissolved oxygen. We had to do that on a little pond at my mother-in-law's house because the fish were dying, and we put an aerator in there. Plant growth and amount of decayed organic material. Okay, so here's the big thing, and I think this is I've done some workshops. I've done some things for lake associations and things like that. One of the biggest problems we fight in northern Indiana is algae blooms. And fertilizers are terrible at getting into a body of water and causing algae blooms. And people, I'll give you a quick story, and I'll end with this one. So I was at a lake association meeting.
The fund committee will be meeting at 8 o'clock.
I was at this meeting, kind of an interesting meeting, and I was talking about, your lake has too much algae, and we need to do something about the algae problem. And it was a legitimate question. Some older gentleman raised his hand and said, "I don't get it." He says, "Why is algae so bad? Don't they give off oxygen? Aren't they a plant?" True, right? And I said, "You are exactly right. The problem is when you get too much of it and it dies, what happens to it?" He kind of looked at me and goes, "I don't know." I said, "It decays. It falls to the bottom and it becomes detritus." We talked about that in notes the other day. Well, then the microorganisms come in and break that detritus down. What do they use? Oxygen. Everybody get it? And that sucks the oxygen out of the water. So if you get too much algae, too much plant growth, too fast, it's fine until it dies. And when it dies, then we're going to get a lot of decayed organic material that has to be broken down by microorganisms that suck the life out of that lake or pond or river. And the smaller the body of water, the worse that is. Okay, so that is something that we see a lot of problems with in this part of the state. Our pond had a big issue with that back in the late 80s. I'm not kidding you. I'm not lying when I say this. I watched a bird go across our pond from one side to the other, hopping across. He wasn't Jesus. He wasn't walking on water, but he could do that because the algae was so thick. It was like a big mat, and all the fish were dying. The pond was this bad. I'll explain why that was later, but now we treat it. You'll see little flags out there at different points of the year, and we put some stuff in there to keep that algae in check so that it doesn't get to that point again. And that's something that you'll see in lots of little small bodies of water in this part of the state. Okay. So I hope that makes sense. Just want to introduce that a little bit. We'll talk a little more about that in class, but we'll go out and I'll talk more about it when we go outside and look at some things too. So, hey, hopefully that makes sense. Highlight what's in red, and we're going to pick up with there and kind of finish up notes the next couple days and wrap things up quickly. All right. Hey, have a great day. If you got questions, let me know. See you later. Have a good day. Bye.